Welcome to the SICSS Festival. The festival is part of SICSS, the Summer Institutes in Computational Social Science. I'm Matt Solganic. I'm one of the organizers of SICSS. The mission of the Summer Institutes in Computational Social Science is to provide open, high-quality training in computational social science to researchers around the world. We're trying to accelerate the growth of the field and ensure that it develops practices that are in the long-term interest of science and society. Each summer since 2007, we've offered 2-week summer training programs for graduate students, postdocs, and junior faculty interested in computational social science. The Summer Institutes offer both social scientists and data scientists, and we define both of those groups really broadly. So far, we've provided this free training to more than 700 participants around the world. This event that you are now attending is part of the SICSS Festival, which is a chance for our alumni to host tutorials and participate in discussions of interest to computational social scientists. This event is a hands-on tutorial about text analysis in Python. The instructor is Austin van Loon. Austin is a Ph.D. student at Stanford. His substantive interests are in political polarization, organizational culture, and workplace inequalities. He uses a broad range of tools to do this research, including automated text analysis, hence this event, as well as machine learning, network analysis, online experiments, and observational causal inference. I'm also very happy to say that Austin is an alum of SICSS-Princeton 2019. As you heard at the beginning, this event is being recorded and it will be posted on the internet so that other people can learn from Austin's tutorial in the future. And with that, I will now turn it over to Austin for the main event. Thank you so much, Austin.
Thank you. Thanks, Professor Solganic. I'll go ahead and share my screen. We'll go ahead and get started here. So hi, everybody. I'm really excited to talk to you all today about this little hands-on tutorial in Python that I developed here. This is a link to the Google Collab notebook. My understanding is that everyone was actually emailed this yesterday, I believe, and then also today. So I won't leave it on the screen for too long, but it's there in case folks maybe watching this video don't have the link for whatever reason. And when you open that notebook, it's going to look something like this, although you might not have this adorable corgi here. That's if you turn on corgi mode in Google Colab. This is basically what the notebook looks like. It's made up of these different cells. There are text cells and code cells. The text cells are going to allow you, or it's where I put some text that basically builds a story around the code that's being ran. So you can kind of follow along at kind of a macro level of how things are going. And what we're doing. And on the right, you can see some code cells, which just has Python code in it. And the really cool thing about Google Colab, which is like a Google Doc for Python code, is that you can actually run these code blocks without having to download any Python software. And another cool thing about it, what really makes it a nice interactive coding experience, is that the results of code that you run actually will show up right below the cell in which you run the code. And so, for instance, we'll mix in the notebook, there's some various visualizations that are made, and those visualizations will pop up right there so that you can examine the results. So I just wanted to kind of introduce that really quickly to kind of talk about what this session is going to be and how it relates to the notebook. So we're going to do kind of an overview of some of the high points of the notebook. We're going to show some chunks of code, and we're going to go through some of the chunks of code in depth. But the hope is that really a lot of the technical details are covered hopefully pretty well in that notebook. And a lot of the nuts and bolts are in there, and the code is really like documented to death. And so hopefully folks can follow along with that. And here we're going to spend a little bit more time taking kind of an overarching view of the methods that we're talking about, and hopefully describing kind of theoretically what's going on with that, and really trying to take a more kind of complementary 1,000-foot high kind of view of the notebook. And then hopefully, I'm really hoping to have a lot of time for questions and discussion. And so if you had a chance to go through the notebook, that's great. And feel free to bring up any questions that you had from doing that. Also, if in the talk we talk about, scraping this endpoint of the Twitter API and you want some more details on that, I'm happy to go to that section of the notebook and talk more about it. But I want to make sure that we leave a lot of room for that in this session. So because of that, I'm not going to go through all the code in the notebook, line by line. We're really going to be trying to take a really 1,000-foot high view. Oh, and I guess I should say also, that being said, because there's so much time for questions, I'm going to stop periodically and ask for questions. So if you have something you want to ask me during the talk, feel free to put something in the chat, say you have a question, or go ahead and feel free to put your question actually in the chat, or raise your hand. And Megan's gonna be helping me kind of take questions throughout. So a quick outline of what we're going to go over in this session. First, we're going to talk about briefly using the Twitter API version 2. We're going to talk about 3 different endpoints specifically relating to the Twitter API. We're going to talk about the timelines endpoint, the sampled stream endpoint, and then the search tweet endpoint. And we'll talk more about those in depth in a second. And then we're going to talk about actually getting our hands on some data, not through the Twitter API, so that everybody can follow along, even if they don't have a Twitter developer account. We're going to talk about downloading that data from a public GitHub repository, and then we're going to talk about pre-processing the text that's available in that data. Then lastly, and I hope this is where we can spend a lot of our time and a bulk of our time, we're going to talk about 2 different ways to analyze differences in word frequency by metadata of text. And specifically, we're going to talk about what's been called the closed vocabulary approach or the dictionary method, and then a more recently introduced open vocabulary approach or differential language analysis, also called shortened to DLA. Right, so I guess I'll go ahead and jump in and I'll check in with questions after each of these sections. So I'm somebody who uses Twitter for some of my research, not all of it. But I've definitely, when I do use Twitter for research, I've definitely gotten pushback and been met with skepticism by some of my colleagues. They'll ask, is Twitter really an appropriate data source to study human behavior? Is online behavior representative of real human behavior? And that's really viewing this in kind of a dichotomous lens. And I really push people to think about this more on a spectrum of when and in what cases Twitter is appropriate for studying certain kinds of human behavior. Right. So, I mean, it's undeniable to say that a lot of social life is actually just playing out on Twitter. Like that is the thing to be observed. And so, for instance, a lot of day-to-day political communication, a lot of day-to-day organizational practices, and a lot of political campaigns, like a lot of it's happening over Twitter. And so to simply ignore Twitter as a data source is really missing out on a lot of opportunity, and you're really missing a chunk of the phenomenon to be explained. But it's also equally laughable to say that Twitter is, the perfect data source for every kind of question. Of course, if you're wanting to study, I don't know, like networks of sexual behavior in high schools or something, you'll probably need more data than what's on Twitter to answer that question appropriately. Okay, so with that caveat in mind, if you are reviewing your research question, you think Twitter might be an appropriate data source for you, what's probably going to be your first step is applying for a developer account. And there's some more links and resources in the notebook, but that's kind of going to have to be step 1. Step 2 is going to be to create a project and then an app, which is kind of confusing, and don't ask me why they do that, but to make these things associated with your developer account. And then once you have an app made, you click on this little key token down here that I've circled in red, and that's kind of roughly what your screen will look like. And that'll give you access to various API keys or tokens. And we're going to be using specifically the bearer token just for convenience. But essentially, that's going to be a password for your associated developer account, your associated app. That's going to tell Twitter that it's you who's trying to access their data, and so they can also keep track of the tweets that you've pulled over any period of time. So once you have your bearer token, you can go to the notebook, and this is a code chunk from the notebook. This code chunk, we're just assigning the values of 2 different variables, this bearer token and tweet fields. And basically, you just need to take your bearer token and replace everything between these 2 quotes with your bearer token. So you can paste that or copy it or whatever. And then that's gonna, then the rest of the code is gonna assume that you've assigned that variable, and then it's gonna use that and allow you to access the Twitter API. And then tweet fields here is just telling the Twitter API what information we want to access. And I won't go into these in depth, but I am going to say that this is just a subset of them. Each of the API endpoints have documentation, and that documentation spells out what and all you can plug into tweet fields. So here's a list, for instance, from one of the endpoints. And we're obviously only using a small subset of those, and that's just for the purposes of, of having something to work with. So first, let's talk about the timelines endpoint. This essentially is an endpoint that allows you to access all the information that's stored on any particular user's timeline, which has all the content that the user creates and also shares, and also has some other information on it. And so, for instance, if you want to study how different news outlets, talk about different news stories, studying that on Twitter might be one place where you can study it, and the timeline endpoint might be a very helpful endpoint for such a project. So I define this function here on the right, get user tweets. And again, I'm not going to go over this function particularly in depth. In the notebook, this is, again, has a lot of documentation, and hopefully, that's helpful for following through it. I'm just going to kind of point to it right now and put it up there so people can see what it is. And then I'm going to show you an example of how to use this function. But basically, it's going to take in a list of user IDs. And so, for instance, in this example, we take my personal Twitter account's user ID, along with Professor Chris Bale's Twitter ID and Professor Salganik's user ID. And then we just pass that list of user IDs, now stored in users, to the function get user tweets. And that's all you have to do to pull basically all the tweets from all three of our timelines. We also pass some other stuff here that I'm not going to get into in depth. Again, it's all really well documented in the notebook, but that's to say, once you've defined a function like this in Python, it can be really easy to access tools like the Twitter API. So now I'm going to talk quickly about data streams that are available through Twitter. Twitter, is getting data basically every second of every day, and then they turn around and make that available to different people in different streams of data. So I'm going to talk quickly about the three kind of main streams that Twitter has available. The first is the fire hose, which is basically 100% of all tweets that are published as they're being published is available in the stream of data. Then there's the Deca hose, or I've also heard it been called the garden hose, which is about 10% of all tweets as they're published. And then lastly, there's the spritzer. And the fire hose and Deca hose, you have to do special stuff to get access to it, but the spritzer is actually available to anybody with a developer account. And so, that's the one we're going to access here in the notebook and in this session. So I defined this function on the right, get streaming tweets in the notebook. And again, apologies for not walking through this line by line, but happy to do that in the question Q&A, afterwards, or the discussion afterwards, if folks feel like that would be especially helpful. But again, it's really, really well documented, I think, in the notebook. And so essentially, this is going to allow you to pass either a T or an N parameter, and then it's going to take care of all the backend stuff for you. And so in the top here's an example of passing this T, which stands for time. And so if you pass T equals 1, for instance, as we do here, it's going to pull 1 second of the spritzer stream and then return those results to you. Versus if you pass, say, N equals 5, like we do here, it's going to pull exactly 5 tweets from the spritzer stream and then return those results for you. So it'll keep pulling until it reaches that N. And so that's as easy as it is to pull from the spritzer stream. And then lastly, I just want to talk quickly about searching the historical Twitter archive. This is a really cool endpoint that's available to many more people in the Twitter API version 2, and I think it's something that's really powerful for social science research. This basically allows you to pass a query to the Twitter API, and it'll return potentially all the tweets that match that query. And queries are very general, and I'll show you an example of that here in a second. I should say this is only available to the academic research track developer accounts. So when you apply for a developer account, you can either apply for a standard developer account or an academic research track developer account. And if you want to get the latter, which just has additional perks associated with it, you just have to provide some evidence that you're actually associated with some kind of academic institution or research institution. So here's this function, query Twitter archive. And it's basically going to take in a query, which I'll show you an example of that in a second, and then a number N, and it's going to return that many tweets from Twitter API that match that query. So for instance, here on the left, here's a code chunk where, maybe I should have taken out this documentation, but an example of us querying the historical Twitter API. We define this query Q, which is saved as a string, but it's basically a code we're going to pass to the Twitter API telling it what kind of tweets we want. And so moving from right to left here, we're telling Twitter API that we want tweets that tag someplace in the United States, tag someplace period, that's this has geo, is not a retweet, is detected as being in English, and contains either hashtag BLM or hashtag Black Lives Matter. So as you can see, that's already getting a pretty interesting body of tweets here with a relatively simple query. In the grand scheme of things, these queries can get quite long and quite complex. But even with only just a couple of conditions, you can start to get at the kind of data that you might want for some sort of research project. And then we're throwing some additional parameters here. So we're throwing expansion fields and start time and end time. And again, I wasn't planning on spending too much time on that because again, it's documented quite heavily in the notebook. But here's an example of us passing that query to the Twitter API and getting back 10 results. Okay, so that's Actually, all the time I was going to spend on the Twitter API version 2, but I did want to open it up and take any questions or comments, and we can feel free to have a discussion here. We should have, a good, hopefully me just talking to you guys is, about 30 minutes, so we should have plenty of time for questions. So were there any questions in the chat, Megan?
Yes, there are a couple of questions. JC, thank you for answering one of them about user ID. We have another one by Philip about whether the spritzer limit is limited by proportion or by absolute numbers.
As in, like, what appears, sorry, the person who posted that question, would you feel comfortable maybe expanding on that?
Yeah, can you hear me well?
Yes.
Yeah, okay, thank you for the presentation so far. Yeah, so my question would have been, if the spritzer was limited by an absolute number of tweets that you can scrape, then maybe that kind of access would be sufficient for very fringe topics. However, if it's always only a proportion, then maybe it would never be sufficient. Does that?
Yeah, so unfortunately there's kind of both limits. So what's included in the sampled stream, my understanding at least, is that it's roughly 1% of all tweets as they're being published, and that's like constant across time. But then also for any of these endpoints, and sorry for not mentioning this, but there are rate limits, what they're called, set on your account. And so for instance, like the total, I believe, like an academic research account, I believe, can pull like 10 million tweets a month total, which, I mean, it's not small by most means, but if you, for instance, have to throw out a lot of data, then that can start to cause you problems. So, for instance, if you're just pulling from the sampled stream, just the spritzer, the raw spritzer, and you're pulling 10 million tweets, but then you have to throw away like 90% of that data because you actually only want tweets that have more information than what you pass to the API, et cetera, then you might be throwing away a lot of the data and you might be left with something relatively small. So it's important that I would highly suggest, I'm only kind of showing code for 3 of the different API endpoints, but there are more. I think there's actually, I don't know the number, so actually I'm not even gonna guess. But it's important that you look over all those API endpoints and pick the one that's most suitable for the data that you want to collect. Does that answer your question, Philip?
Yeah, thank you very much.
Yeah, of course.
All right, JC, do you want to ask your question?
Yeah, hey Austin, hope you're well. Have you found a way to figure out what all the API has, like how many tweets for a certain query, without just going through the pages one by one? I don't know anyone who's figured this out. It seems really annoying.
Oh, that's interesting. Sorry, I'm just thinking for a second. I have not come across anything like that. It seems like something that the Twitter API, especially with version 2, because they tried to really respond to a lot of people's, like, oh, why doesn't the API have this? They tried to really respond to those, and I would think that would be something they would include. But yeah, I'm not familiar with the method for doing that. So yeah, apologies, but that is something that would be definitely useful. Megan, were there any more questions?
Looks like that's it.
Great. Okay. So now we'll go on to the kind of data that we're planning to use for analyses today. Specifically, we're going to talk about downloading some data from a public GitHub repository and some of the concerns that might arise with downloading data just from places on the web. And then we're going to talk about pre-processing the text data that's a part of that. And I will say, I'm actually going to go through line by line on the pre-processing. I mean, it's not very many lines of code, but I think it's one of those key things that, like, if you walk away from this with only one thing, maybe it's, you have a little function or an idea of how to pre-process text in Python. So this is a public GitHub repository called Tweets of Congress. I think it's just a fantastic, resource especially for tutorials like this. But essentially, this is a couple of folks who got together and built a pipeline to automatically scrape the timelines of all Twitter accounts associated with a member of the US Congress and some other congressional entities each day. And they've been doing this since like June, I think, of 2017. So it's this great treasure trove of data if you're interested in, for instance, political communication in the US, et cetera. And the data is organized just as like just to help make sense of this code a little bit. The data is stored such that each day of tweets is on a separate file. And so basically this code makes a list of all the URLs for each day in 2020, and then appropriately formats the URL And then the single line here is really doing the heavy work, this raw tweet df equals pd.concat. And essentially what that's going to do is going to take the files that are at each of those URLs that we've compiled, and then pull the file, read it into a usable format, and then append them all together and do a single nice pandas data frame, which looks like this down here in the bottom corner. And as you can see, we end up, for just the year 2020, we end up with a bit more than 1 million tweets. And we end up in this GitHub repository, they store 7 different variables. Note here, the text column is probably the one that we're potentially most interested in. It's the text of all the tweets that each member of Congress tweeted out over the year 2020. So, yeah, okay. Oh, yes, and then when you're pulling this much data from any kind of source, you should take a second and think about the possible repercussions. So for instance, here we're pulling all this data from GitHub, which is owned by Microsoft. So I'm not too concerned about crashing their servers. However, if you were pulling this much data from, say, a local newspaper or a newspaper in like some rural area, for instance, you might actually like shut down their servers, or you might incur them a lot of costs, etc. And so you should, for instance, if you're pulling data from a website, you should try to seek out the terms of use for that website. If you're really not sure if you can scrape this data or not, maybe talk to a librarian at your academic institution if you're affiliated with one. That can be a very helpful resource. Great, so now let's talk about pre-processing this text data, because if you'll see, sorry, I'm going to go back a sec. If you look at this text data, it's not what we would call clean text data at this point. So now we're going to make basically a copy of this data frame that we're going to end up cleaning. And so I'm going to show you, kind of reveal one line of code at a time to show you how I went about pre-processing this text in the notebook. So first we're going to make a copy of that pandas data frame, but with only a subset of the columns. So we're just going to look at screen name, time, and text. Then we're going to use a single line of code to remove all retweets using a simple heuristic. If the raw text of the tweet contains capital R, capital T, space @ then we're going to assign it being a retweet. In some analyses I've done on other work, we've had large samples of data in which we know for sure whether a tweet is a retweet, and we use this heuristic, and it's over 99.99% accurate in like general population Twitter. So this seems to be a pretty good heuristic. Of course, if you're doing this for research, it'd be ideal to know for sure whether something's a retweet or not. But for our purposes, this will be fine. Then cleaning the tweet is basically going to be us passing the text of each tweet through this function that we're going to define clean tweet, and then replacing it with what comes out of the function. And so now I'll walk through each line of that clean tweet function, which is really going to be doing the heavy lifting here. So first we're going to lowercase the text of the tweet, and lowercasing is as simple as that, text.lower. Then we're going to tokenize. We defined this object called tokenizer in the notebook prior to doing all of this. It was also just one line of code. I probably could have included it here. But if you define that object, then tokenizing is as simple as this. And tokenizing, I should say quickly, is taking like a natural text like hello, nice to meet you, and changing it into chunks of meaningful text. So it'd be like a list of the words hello, nice to meet you as like separate elements in a list. And then we're just going to remove stop words and then some white space that happened to appear in our corpus to some degree with these 2 lines of code. And then that's it. And that's these lines of code basically clean the data to a point where I would say it's pretty sufficient for analysis at that point. I should also say, this could very easily be like a single line of code. I've expanded it out so that folks can, follow along more easily. But hopefully this shows you that like pre-processing in Python's like fairly readable and not too difficult. And this exact code here can be used for a whole bunch of different social science projects, and is a very reasonable starting point in my opinion for pre-processing text. So we've talked about using the Twitter API version 2, and then we've also just talked about downloading some data and pre-processing it. And I wanted to take a second and open back up for questions if there were any additional questions. No? Okay, cool. Maybe if I'll just do a quick time check. Cool, we're doing good. So now we're going to talk about 2 different methods for analyzing the frequency of words across documents and text, across text documents, excuse me. Specifically, we're going to be talking about the dictionary method or the closed vocabulary approach, as well as the open vocabulary approach or differential language analysis. And I wanted to take a second and kind of describe a theoretical lens or an analytical lens, like what are the differences between these, and really point out some of the key distinctions between these two. I'll say very briefly, for those who are familiar with this language, the method on the left is meant to be deductive. It's closed vocabulary. You have some theoretical priors that decide what linguistic features you look at. Whereas the open vocabulary, it's more inductive, and it's meant for you to kind of learn something about a phenomenon that you're interested in. So this is kind of a little diagram to represent what happens in the closed vocabulary approach. The idea is that an analyst comes to the setting with some kind of theory about how things work. And then that theory then guides the development of some testable hypotheses. And those hypotheses suggest some linguistic features that you should measure about your corpus of text. And then that should also suggest some relationship with some kind of metadata. And we'll go through an example of this in a second. But then the selection of those linguistic features and metadata suggests some statistical test, and the results of that statistical test reflect then back on the validity or soundness of the theory. And so, for instance, in our example that we're going to be exploring in the notebook, there's a theory out there in the literature called moral foundations theory, and some of the work in there suggests that Democrats and Republicans use different kinds of moral language, and they evoke them differently. And so that theory also suggests some linguistic features that we should measure about the text that's used by these members of Congress, and also suggests that it should be related to their party affiliation. And so then having those two different features, we can then do a statistical test to see whether it's consistent with the propositions provided by the theory. And so we start with a theory, and we're going to test basically the claims provided by that theory. The open vocabulary approach is quite different, and hopefully that's not being blocked by any speaker view or anything. You're going to start with some data, and then you're going to essentially derive some linguistic features that describe that data. And that, I know that's very abstract, and that's because it can be a lot of different things. But so, for instance, in our case, we're going to just select as linguistic features the prevalence of the 500 most common words in the corpus. So we take a list of the 500 most common words, and then we measure how often each member of Congress uses those words. You can also do things like topic models, which I won't get into what that is here, but essentially it's using statistical collocation to statistical collocation of words, sorry, to summarize the content of documents. And so then that comes up with a numerical summary of what's contained in each document. And so you can also use that as a set of linguistic features. And then for each linguistic feature, so in our case, each of the 500 most common words, we're going to do a statistical test to see whether that specific linguistic feature is associated with the metadata of interest. And so, for instance, in our case, again, that's going to be party affiliation of members of Congress. So then after all these different statistical tests, we're going to summarize the results and then provide that summary to the analyst. The researcher, you, and then the idea is that using human intuition, the researcher can then derive some kind of theoretical insights, potentially useful for building theory later. And again, we're going to go through examples of both of these. I know especially like the open vocabulary approach took me some time to wrap my head around, so I'm actually going to go through a published example of that, hopefully relatively quickly, with the hopes that that'll help put some flesh and bones on this. But so just to hit some key bullet points of how these are different. In the closed vocabulary approach, your choice of linguistic features is based on your theoretical priors, right? So you have some theory about the world, and that theory is going to drive your selection of linguistic features. Whereas on the right, your linguistic features are based on empirical patterns in the data. So again, this is like what words are most often used, or you're going to use topic models to summarize the content of these documents, and you're going to use the prevalence of those topics as your linguistic features. Now, this puts the burden of validation on different parts in the pipeline. So on the closed vocabulary approach, for instance, the thing that really needs validation often is, is this movement from theory to linguistic features, right? So for instance, the theory might say something broad about, evoking different moral values, right? But then to say, that corresponds to using these particular linguistic features in tweets, that typically will require some kind of validation. Sometimes that's additional studies. Sometimes that's simply through logic or argument, et cetera. But you kind of typically will need to validate that operationalization here. On the other hand, on the open vocabulary approach, where a lot of validation might be necessary to convince your reader, for instance, is actually this link, is from going from the results of a statistical test to insight, specifically the step of interpretation, right? So you might see, for instance, and you'll see like there are these particular words in our corpus that are highly associated with being a Democrat. And then from that, we might make some interpretation about how maybe Democrats and Republicans are different, for instance. But to really, validate that interpretation, you might have to, for instance, go back to the raw text and read various documents so as to provide support for that interpretation. Lastly, these things are at base very useful for different things, or useful for very different things. So for instance, on the closed vocabulary approach, I mean, this is, bread and butter deductive testing, right? So this is useful for testing hypotheses and testing the soundness of theories. Versus open vocabulary approaches, they're really meant to be useful for discovery. And so, for instance, you might not, you hopefully will know more coming out of this analysis, or have maybe different theories coming out of this analysis than you might have had before. Whereas in the closed vocabulary approach, you're testing a theory you already had. So again, I hope that's somewhat clear, but we'll go through a published example right now of the open vocabulary approach, so that you kind of have a sense of what you can get out of this open vocabulary approach. Yeah, maybe I'll do that and then take questions. So sorry if this was kind of a hard slide to format. So apologies if it's a little hard to see some of the figures in here. And so this is a paper published in PLOS One in 2013 by Schwartz et al. And it's kind of the paper that introduced differential language analysis formally. And what they did is they essentially had, I think, 75,000 roughly Facebook users do some personality assessment, report various demographic characteristics, and agree to give the researchers access to all of their Facebook status updates. And so then they're going to do this open vocabulary approach to see what linguistic features are associated with gender, with age, and with personality. And so they summarize the results in these word clouds. And I won't get too much into the details of how they describe these word clouds, though maybe you can pick it up from this key here. But essentially, these are the words and also sets of 2 words that are most associated with the person identifying as female. And so folks who identified as female more often, for instance, use the word shopping in their Facebook status updates, more often use the word excited, etc. And then folks who identified as male were more likely to use these words in the center cloud. These more peripheral clouds show the topics and the prevalence of words in those topics that are most associated with these same outcomes, but I'm going to kind of skip over those so as to not have to deal with the question of what topics are. So again, the hope here is that, maybe some of these might accord with your expectations, and maybe a lot of it, maybe, I don't know, seems obvious to you, or is maybe not that interesting, but the hope is that some of it kind of makes you maybe cock your head a little bit, or makes you like squint your eyes and think that that's interesting, and hopefully gives you some kind of insight about how maybe gender is presented on social media, at least in the United States, where I think most of their population was from. In the middle here, they do this same kind of analysis with age groups. And so here you can see the language of 13 to 18-year-olds, the language of 19 to 22-year-olds, et cetera. And I think there's also a fine point to be made here. Some of the stuff, it probably is what we would call an age effect, right? So stuff like semester, classes, studying in the library, things that, most people who attend college are roughly in this age range. And so this is really like at that point in your life, you're likely to be talking about those things. But for instance, if you look at the 30, 65-year-olds, I think we see some stuff that's, for instance, a cohort effect. So for instance, FB friends here, this term here. I don't think it's likely that once these 23, 29-year-olds become, 30, they're suddenly going to start using FB friends in their status updates. I think that's more something about folks who are maybe less attuned to technology, because a lot of these technological developments happened for them later in life. And so they're using more what we would consider maybe, or what younger folks might consider more awkward language in their status updates. And then lastly, they do this for personality. And so we're, for instance, looking at extroverts versus introverts. and those who have high levels of neuroticism versus low levels of neuroticism or high levels of emotional stability. This is where they really got a lot of theoretical bang for their buck. And so, for instance, in the emotional stability cloud here, there was some stuff that the personality researcher, the literature, I think would have predicted. So I think a lot of stuff, for instance, about religious affiliation. So you see here like praise, blessed, God is good. I think the personality literature, I believe, already knows that religious affiliation is kind of associated with emotional stability. But some of this stuff was kind of novel. So a lot of stuff about sports, for instance, they kind of provide as new theoretical material and potentially something that can be followed up by future research with different kinds of methods. And so again, this is a kind of published example, a really high overview of some of the results. So maybe I'll take a second, take any questions about either the open vocabulary approach or the closed vocabulary approach and how they're different. If there are any questions about that, I'm happy to take those now. All right, then moving forward, now I'm just going to talk about the two analyses that we did in the notebook. Well, two of the analyses we do in the notebook. One that's kind of prototypical, the closed vocabulary approach. One that's prototypical, the open vocabulary approach. So there's a little bit of background for this because we have to have some theory we're working with for the closed vocabulary approach. There's this theory in moral psychology called moral foundations theory, which essentially argues that human morality can be boiled down to a couple of key organizing principles. And I should say this is not necessarily an endorsement of that theory, but it's particularly convenient for us to use it in this example. So that's why it's making an appearance here. So some folks in this tradition have argued and shown that liberals and conservatives differently evoke different moral foundations. So specifically, liberals tend to evoke some set of moral foundations much more than the others, and conservatives more rely on all the different moral foundations. So from this work, one could reasonably derive a couple of testable hypotheses about how liberal members of Congress and conservative members of Congress would evoke these different moral foundations on their Twitter accounts. And so folks in this tradition have also released this nice public tool called the Moral Foundations Dictionary, which allows you to do these analyses pretty straightforwardly. And it's basically lists of words associated with each of these supposed moral foundations. And so, for instance, here you see there's authority, fairness, harm, in-group, and purity. I also defined this function in the notebook called dictvec that allows you to pass a string or a list, and then also an appropriately formatted dictionary like the Moral Foundations Dictionary. And then it will produce this kind of output that allows you to analyze how often were these different words used in the text that you passed it. So then we make a version of our data frame that's at the user level. So for each member of Congress, we have all the Twitter language that they produced. And we're essentially going to measure out of all the words they used in this entire dictionary, what proportion of them belong to the fairness categories, to the harm categories, in-group categories, and so on. And then we're going to compare whether Democrats and Republicans had different values for these. And so, for instance, these are kernel density estimates, which are basically just smooth histograms of the proportion of words used by members of Congress, or more words that members of Congress used that were in the fairness category, and the harm category, and the in-group loyalty category, and the authority category. And they seem to be different. They seem to be different in the ways that would be suggested by the theory. And then we can test those. Specifically, here we use a Mann-Whitney U-test. And that supports the idea that these are significantly different distributions, and therefore provides support for the theory. And so I would say this is a pretty prototypical example of a kind of dictionary approach to text analysis, and is very much something you could see. In fact, there's analysis that's actually fairly similar in this paper. I believe they use sermons though, yeah. So moving on to the open vocabulary approach analysis that I want to talk about today. I think it's instructive. So if you'll remember, for the open vocabulary approach, if we have, say, 500 linguistic features, we're going to run 500 different statistical tests. But I think it's instructive to first think about if the case of where we only have a single linguistic feature. So let's imagine, for whatever reason, we only had a single linguistic feature that we were using, and that was the prevalence of the word black. And so then for each member of Congress, we're going to measure what proportion of their Twitter language is the word black. And then we can compare those proportions across political party. And so, for instance, you see here on this graph that for Republicans, about 0.02% of their language is the word black. And for Democrats, it's somewhere between 0.08 and 0.09% of their language is the word black. And using a logistic regression that suggests that this is a significant difference across these two groups. So that's a single logistic regression, the analysis of the prevalence of a single word. And we're going to do that for all 500 words that are the most common 500 words in our corpus. And so that's as simple as this. So first, we're going to define a numeric vector for whether somebody identified as a Democrat or not. And then we're going to use this function I defined in the notebook called WFLogit, which is just going to do this test basically for each of the words in the vocabulary. Then, importantly, we have to correct the p-values here for multiple testing. So the idea here is if you run 500 statistical tests, you're going to end up getting some stuff that's significant that really shouldn't be, just because of how statistics works. And so it's important that you correct your p-values for multiple testing. And basically all that means is you're going to be raising the bar for what counts as significant. There's many different corrections one can do. And I don't want to talk about it too much here, but here we just do the most conceptually simple one, which is called the Bonferroni correction. And there's a couple ways you could implement this, but here we're just going to basically we just multiply the p-value by how many statistical tests we ran. So since we ran 500 statistical tests, we're going to multiply our p-value by 500. And then we're just going to look at the set of those results, the set of those words that even after this correction are still significant at the 0.001 threshold. And so this is what you get out of that. These are the words on the left that are most predictive of a member of Congress being a Democrat. That is, given the proportion of words that somebody used that were affordable, the higher that number is, the much more likely they were to be a Democrat. As you can see, this is after correction, so that's a very significant value. And then you can see, so affordables here, protections, climate, conditions, mask, democracy, male, etc. And on the Republican side, you see the same words that are most predictive of being a Republican. So you have Pelosi, China, freedom, enforcement party. And then the next step here would be interpreting this and trying to learn something about the phenomenon from these results, from this summary of the results. And so just a couple of things that came out to me as I was looking over these lists. One thing was that if you look at the Democrats list of words, we have protections, whereas in the Republican list, we have protection. And I think that there's some, maybe low-hanging fruit interpretations of that, but given that, I would certainly go back to the raw text and maybe look at some of these tweets directly that contain these different words, and maybe look at what are the tweets that where Republicans use the word protections and where Democrats use the word protection, and try to see how these two very similar words are used very differently by these parties, by members of these parties. Another thing I noticed by looking at the overall list is that in the Democrat column, right, we have a lot of things that are kind of platform issues, right, like climate, like housing, where you really don't see those as much in the Republican list. And so from that, you might be learning something about political communication. And again, I would probably be looking at the raw tweets to validate that whatever interpretation I were to arrive at. And yeah, that was essentially all the stuff I was gonna be talking at you about, and then I was hoping that we could maybe start in a discussion, and looks like we have a good amount of time for that. But just to quickly recap over what we went through today, we talked about using the Twitter API v2, and we talked about 3 different endpoints of the Twitter API and how you can access data differently through the Twitter API. Then we talked about downloading some data for analysis from a public GitHub repository, as well as pre-processing text data in Python. Then we talked about 2 different methods for analyzing word frequencies across documents. We talked about the dictionary method as well as DLA, or differential language analysis. And with that, open to having a conversation and taking questions. And I'll go ahead and maybe I'll stay on here for now, but if folks want to move over to the notebook, I'm happy to do that. Or, you know, if there's no questions or discussion to be had, that's also totally fine. Megan, were there any questions?
Yes, we've got 2 questions in the chat. First from Monica. How can open vocabulary be used for topic modeling? And could you give us an example? And then a question from Antonio about whether you've done any stemming in Python.
Yep. So the first one, topic model. So the idea here would be here, for instance, in this WF logit function, what we do is we take, say, a word, say, for instance, black, and we measure the prevalence of it in each member of Congress's Twitter corpus, like their set of tweets. How often do they use the word black? And then we're seeing whether that correlates with party affiliation. If you were to do this with, say, topic modeling, you could instead say train a topic model on the entire Twitter corpus, and then say for each member of Congress, measure how often are they using topic 1 versus topic 2 versus topic 3 and versus topic K, right? And then for each of those topics, you could see whether that's associated with the party affiliation of the member of Congress. And so, for instance, just to go back to this published example, let's maybe take away some of these. So, for instance, in this gender example, these are the I don't exactly remember how many topics they had, but I'm sure it was in at least 100 or so. So if let's just say it was 100. So they ran that kind of correlation of topic prevalence with gender for each of the 100 topics. And these are the ones that, after correcting for multiple testing, were still significantly associated with gender. And so then you'd be picking out the topics that are most correlated with the outcome of interest. And you still have a principled way of doing that without, you know, having a hypothesis about which topics are explicitly going to be correlated with the outcome of interest. And so, sorry, I'm sorry, I forgot who asked that question, but does that answer your question?
She says, yes, thank you.
Oh, yeah, of course.
And the other question was about stemming from Antonio, and then we have one more.
Okay, great. So stemming, yes, I have done stemming, but depending on the analysis, I'm sometimes for, sometimes against stemming. It totally depends on your research question and what kind of analysis you're going to be doing. But for instance, if we had stemmed here, right, protections and protection would have been the same word. Which, you know, might not be ideal, and it would perhaps obfuscate an important difference that we could have found with differential language analysis. But obviously there's the trade-off where you have more instances of a word if you stem all the different forms of it. So if you're stemming in Python, you know, there are some very easy tools that, you know, that can be implemented in a style very similar to, say, sorry for the rapid going through here. But so, for instance, we used a tokenizer here. This is something we defined before this block of text. And this was something that we actually took from NLTK, Natural Language Toolkit, which is a really great library for natural language processing. That same library has very similar objects available for stemming. And so specifically, if you look up like NLTK Porter Stemmer, that's a very often used way to stem. And so then you would just have a line of code above here somewhere where it'd be like stemmer equals, and then you'd have to import, and I don't recall exactly what that command is. But then here you would just add another line. Well, you'd add another line like here. Well, maybe actually below here, where you just say, where you would just call the stemmer on the string, and then it would stem each of the words in that list. Does that answer your question? Sorry, was it Antonio?
Yes, thank you.
Yeah, of course.
Okay, so Camila says, this is really nice. Can you talk about using text analysis in Python with other sites and mediums such as Reddit or Bills? Also, how do you stay up to date with coding languages?
Yeah. So let's see, let's start with, so keeping up to date with programming languages as a whole is a little bit impossible, I think. You know, certainly there are some websites that'll like point you to new libraries and stuff, and I think that that's a really helpful tool. So Medium's a little bit hit or miss for me, but it's kind of the thing that I mostly rely on. And certainly checking out the code of people who are doing this work. So if you're looking like following the work of folks who do computational social science and you see that they have a replication package for a paper you really liked, you should definitely check that out and see, for instance, what libraries they're using. But if you have particular libraries you're set up, you're using. So for instance, I really heavily rely often on Pandas for most of my data sets, unless they're like really, really large. And then NumPy and scikit-learn. These are all libraries that have websites, and they kind of maintain a list of all the updates and stuff they're doing. And they have central like resources of all the functionality of their libraries. And so that can be a really good way, like if you know just a couple of functions from NLTK, for instance, maybe visit the NLTK website and see what other kind of functionality those libraries have, and then be watching them for when there's updates and stuff. And that's, I suppose, one way to keep up with it. Because really, Python is a really simple set of tools that a lot of people have built really incredible tools out of. And so if you can keep up with some of these more libraries and you can kind of learn how to use those to do your research, I think that's a totally fine way to kind of go about doing these kinds of analyses. Oh, sorry, and you had another question, which was, sorry,
Yeah, it was, can you talk a little bit about using text analysis in Python on other mediums, such as Reddit, Bills?
Yeah, so there are certainly some sites where it's easier than others. I've personally never gone in and taken Reddit data or scraped Reddit data, but I know multiple people who have, and talking to them about it, it seems like it's relatively easy. But yeah, I can't speak too much to that, I guess, but I know sometimes if there are webs, like I've assisted on projects where there's like, for instance, like South Korean newspaper archives, for instance, is one thing I've helped with. And they'll have a website that you kind of have to learn the structure of the website, right? So for our GitHub repository, like I needed to know that all the files could be found from this URL plus some data at the end, right? And then from that, I could figure out how to pull all the data together. It can be more difficult when it's, for instance, like a newspaper website or some like website out in the wild that's not something like GitHub, because learning that structure can be a bit more complicated, and then learning how to scrape the web pages can be more complicated too. And I know it's not super helpful. That's because it really depends on the website. Some websites are relatively easy to traverse. You kind of have to look at the HTML often and try to see if you can figure out a way to algorithmically scrape the HTML to find the information you want. And some websites, it's just really, really complicated. I can also say there are different packages for scraping just websites in general. Sorry, I can't think of any off the top of my head, but simple Google searches will probably give you so many answers. You'll have an embarrassment of riches problem going on. But a lot of those packages can make scraping just your run-of-the-mill websites kind of a bit easier. And there are some sites where it just seems like, yeah, like Facebook, it seems like it's just too difficult right now to get data unless you're working with somebody from Facebook, or sometimes Facebook sets up opportunities for people to use their data. And then those are obviously incredibly valuable if you can get access to those kinds of websites as well. So I think that kind of lays out the categories, right? There's some places that have APIs like Twitter, and those are kind of ideal for research, and they make a lot of their data publicly available. There are websites that are kind of in between, where sometimes they're okay with you scraping, but it's not in a very easy to use format, and you kind of have to dig through the weeds of the HTML to find that data. And then there are websites or like platforms like Facebook that really try to not let you scrape anything, and you have to be you kind of have to get special access through them. So I hope that's somewhat helpful, or if you have maybe other follow-up questions, I'd be happy to follow up on that.
Okay, Tahira asked, can you apply open vocabulary approaches to other types of data, such as abstracts and articles?
Yeah, you can do this with in principle, as long as you have some kind of text data from which you can derive linguistic features, and you have, I mean, here I said metadata, and that's the way that it's been done. And so, for instance, some of the analyses of this have been like looking, so this was the example we went over, sorry, was Facebook status updates. They've also done stuff with, for instance, Twitter, and that's been like looking at the Twitter discourse in a county and predicting heart disease or well-being of the residents of those counties. And so you can do this with any kind of social media data. If you want to do stuff with like science article abstracts, that's also, I think that would be a really cool project. And so you'd be like looking at maybe the most common words used in different abstracts, or you'd be looking at topics that you train on the corpus of abstracts. And then you'd be associating that with some kind of metadata, right? So this could be, the citation count maybe of the article, or the prestige of the university that the authors are from, or any kind of metadata about the article you can imagine. And then just like we did, in this example, you just test whether each of those linguistic features is associated with the metadata of interest, and then appropriately correct your p-values, create a summary of the results, and then present that as kind of results. So, and again, just to kind of know, or I guess maybe not again, but to say, but I didn't say explicitly, there's different ways, obviously, to summarize these results, right? So here they do this word clouds, which I know, for instance, Professor Chris Bale's not a big fan of word clouds, but I think in this case, they're quite useful, actually. And obviously, we did just like a simple kind of list here. And there's many different ways you can summarize the results. You could probably come up with 1,000,001 different ways to do this in ways that would be helpful for different respects. But yeah, I could certainly imagine, like with scientific articles, seeing the words most associated with citation count. And I think that would be like super interesting. Great.
Okay. We are at the end of time. So we were, please all join me in thanking Austin for an amazing tutorial covering a huge amount of ground very quickly and very clearly, and for providing the notebook that we can take away from this activity and continue to play with and learn from. So thank you, Austin. We're going to stop the recording now.